Hello Year 9. Today we're going to learn about pressure. Okay, so this is a word you've heard before. Some of you might have an idea about what it's about. You might have a notion of what it means, but we're going to talk in more detail about where it comes from. So, pressure is the force on an area, and it's generally caused by the collision of particles. Okay, so that's the part you might not be aware of. So you might be aware of this idea of pressure being a force, but when it comes to the particle part, you might not be so clear on that. So we're going to go through each of gases, liquids and solids in turn and talk about pressure in each one. So we're going to start with pressure in a gas. Okay, and for that we're going to need a container. So here is my container. All right, it's just like a box. It might be a cardboard box, might be a lunch box, could be anything. Okay, but it's a box, and inside there I've got a gas. Now you'll remember that a gas, in a gas, the particles are arranged far apart, and they're moving quite fast in all different directions. All right, so what happens is, as the particles move around, so this particle might be moving in this direction, and this particle is moving in this direction, all right, as they move, eventually they're going to collide with the wall and then bounce off. They're going to come down here, collide with the wall, and then bounce off. Collide with the wall and bounce off. And it is this collision here, that causes pressure. Because this collision here exerts a force onto the side of the container. Okay? Now that's just like if you imagine you have a tennis ball in your hand and you throw the tennis ball at the window in your room. Okay, it's going to bounce off the wall, so it's going to bounce off the window, okay? But if you throw it hard enough, it's going to go through the window, isn't it? And that's because there's a force from the tennis ball onto the window. And in the same way, there's a force here from the particle onto the side of the container, all right? So there's a force exerted on the container from the collision of particles. Okay, now in a gas you wouldn't really have 1, 2, 3, 4, 5, 6, 7 particles. You'd have millions and billions and trillions of particles, loads and loads. And even though they're all really tiny, so each individual one only gives you a small force, because there's trillions and trillions and trillions of particles all colliding with the walls at the same time, it all adds up. Okay? So, now that we know that the force inside of a container is caused by the collision of particles with the sides of the container, we can start to think about different things that can happen. So, let's think, first of all, what if, so let's go number one, what if I add more particles? All right, so I'm going to add more gas particles into my container. All right, so you can imagine more gas particles, like this. What's that going to do to the pressure? Well, now that there's more gas particles, more of them are colliding with the wall at once. So what's that going to do? That is going to be, it's going to increase pressure. Increase pressure, because more particles equals more collisions. And that's what's happening when you blow up a balloon. You start blowing out this, at the start there's nothing inside the balloon, and then when you start blowing into it, you're blowing in all carbon monoxide molecules maybe some oxygen that's left over, some nitrogen that's left over. All these particles are going into the balloon, and because there's more particles, the pressure increases. So the force, you can imagine, if you've got a balloon like here, and you're putting in more particles, and these are all the particles inside, they're all pushing against the sides of the balloon. And the more you put in, the more they push against the side of the balloon, so the bigger the balloon gets. All right? Okay, so that's what happens if you add more particles. Now, number 2. What if I make the container smaller? All right, so how many particles did I have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay, now I'm going to get a new container. This is my new container, and you can see it's much smaller than my old container. Now, I've got 18 gas particles in here. The same number of gas particles. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So, what do we think now about the number of collisions with the side of the container? Well, because they're all so much closer together and so much closer to the walls of the container, they are going to collide with the side of the containers much more often. All right? So, by making the container smaller, I also increase the pressure. Okay, because smaller volume equals more collisions. All right, now obviously if I was to make the container really, really big, if I had a container this big, okay, it would take a really long time for you to hit the wall if you were a particle, so the pressure would go down. The same as if you take particles out, the pressure will go down as well. All right, now the third thing we need to think about is, so we've done, what if I add more particles? What if I change the shape of the container? And number 3 is, what if I increase the temperature? What's going to happen then? Okay, well, if I increase the temperature, increasing the temperature, what does that mean? It means that the particles have more energy and if the particles have more energy, what do? It means that they increase their speed. So the particles move faster. Okay, and if they move faster, it means they're going to collide more often with the surfaces in a container. For example, let's suppose I've got 2 particles, particle A and particle B. Okay, particle A doesn't have very much energy, so it's not going very fast. But particle B's got loads of energy. It's going really, really quickly. All right, what's going to happen? Well, particle A might come along here and hit this wall, and then it will eventually come down here after a while, and it will hit this wall. But particle B is going really quick, so it's going to go bang, 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 bang. Okay, so you can see that the faster the particle moves, the more collisions there are. Okay, so there we have our 3 different situations for pressures in gas. Okay, so I should have said here that increase in temperature therefore is an increase in pressure. Increase pressure. Okay, so you now know What happens if you change the number of particles in a gas, if you change the size of the container of a gas, and if you change the temperature of a gas. Okay, and if you are worried about remembering those, you can go ahead, put those on some flashcards, because it's really important that you know about those 3 different things. And I'm going to give you a link in the task to a simulation, a physics simulation, where you can change the number of particles, the size of the container, and the temperature, and you can see what effect that has on the pressure. Okay. Next, we're going to learn about pressure in liquids.